Let's take a look at one of the homework problems about parabolic reflectors. So you can see an example of a parabolic reflector here. They're often used to collect solar energy onto a long thin tube that has some kind of heat transfer fluid in it, and then you can store that heat or use it to make steam to run a turbine and make electricity. Right now these parabolic mirrors in the picture are pointing directly to the right, but we could imagine them pointing straight up and down. And here's the formulas from the homework that show a parabolic mirror with the front surface in orange here and the back surface in green. And we're asking what's the area between that orange and green curve, because that's kind of like that is the thickness of the glass that you would need, and then the entire trough would be kind of coming out of the monitor and into the monitor toward you. So this would tell you basically the amount of glass you would need per linear foot of the whole parabolic assembly. So go ahead and compute the area between those curves. Don't worry about the whole into and out of the monitor thing. And then once you've computed that, compare that to how much glass it would take to make a flat mirror of where the upper surface is 1 centimeter above the axis and the lower axis is 1 centimeter below the axis. Another interesting thing to think about here is the mirror getting thinner out toward the edges here. It certainly looks thinner here than it is there. So that's an interesting thing to think about. Not needed for the class, but interesting.